Mouse computing.
In computing, a mouse is a pointing device that detects two-dimensional motion relative to a surface. This motion is typically translated into the motion of a pointer on a display, which allows for fine control of a graphical user interface. Physically, a mouse consists of an object held in one's hand, with one or more buttons. Mice often also feature other elements, such as touch surfaces and wheels, which enable additional control and dimensional input.
Naming.
The earliest known publication of the term mouse as a computer pointing device is in Bill English's 1965 publication Computer-Aided Display Control. The online Oxford Dictionary's entry for mouse states the plural for the small rodent is mice, while the plural for the small computer-connected device is either mice or mouses. However, in the use section of the entry it states that the more common plural is mice, and that the first recorded use of the term in the plural is mice as well, though it cites a 1984 use of mice when there were actually several earlier ones, such as J.C.R. Licklider's The Computer as a Communication Device of 1968. According to the 5th edition of the American Heritage Dictionary of the English Language, the plural can be either mice, or mouses.
History.
The trackball, a related pointing device, was invented as part of a post-World War II era radar plotting system called Comprehensive Display System, CDS, by Ralph Benjamin when working for the British Royal Navy Scientific Service in 1946. Benjamin's project used analog computers to calculate the future position of target aircraft based on several initial input points provided by a user with a joystick. Benjamin felt that a more elegant input device was needed and invented a ball tracker called rollerball for this purpose. Whilst patented in 1947, only a prototype was built and the device instead kept as a secret outside military. Another early trackball was built by Tom Cranston, Frederick Linkstaff and Kenyon Taylor as part of the Royal Canadian Navy's DATAR, Digital Automated Tracking and Resolving, system in 1952. DATAR was similar in concept to Benjamin's display, but used a digital computer to calculate tracks, and sent the resulting data to other ships in a task force using pulse code modulation radio signals. This trackball used a standard Canadian 5-pin bowling ball. It was not patented, as it was a secret military project as well. Independently, Douglas Engelbart at the Stanford Research Institute, now SRI International, invented the first mouse prototype in 1963, with the assistance of his lead engineer Bill English. They christened the device the mouse as early models had a cord attached to the rear part of the device looking like a tail and generally resembling the common mouse. Engelbart never received any royalties for it, as his employer SRI held the patent, which ran out before it became widely used in personal computers. The invention of the mouse was just a small part of Engelbart's much larger project, aimed at augmenting human intellect via the Augmentation Research Center. Several other experimental pointing devices developed for Engelbart's online system, NLS, exploited different body movements, for example, head-mounted devices attached to the chin or nose, but ultimately the mouse won out because of his speed and convenience. The first mouse, a bulky device, pictured, used two wheels perpendicular to each other, the rotation of each wheel translated into motion along one axis. Filed in 1967, Engelbart received patent US 3,541,541 on November 17, 1970 for an XY position indicator for a display system. At the time, Engelbart envisaged that users would hold the mouse continuously in one hand and type on a 5-key chord key set with the other. The concept was preceded in the 19th century by the telautograph, which also anticipated the fax machine. On October 2, 1968, just a few months before Engelbart released his demo on December 9, 1968, a mouse device named Rollcall, German for rolling ball, was released that had been developed and published by the German company Telefunken. As the name suggests, and unlike Engelbart's mouse, the Telefunken model already had a ball, as seen in most later mechanical models up to the present. It was based on an earlier trackball-like device, also named Rollcall, embedded into radar flight control desks, which had been developed around 1965 by a team led by Rainer Malabrin at Telefunken Konstanz for the German Bundesanstalt für Flugsicherung, D, as part of their TR-86 process computer system with its SIG 100-86 vector graphics terminal. When the development for the Telefunken mainframe TR-440, began in 1965, Malabrin and his team came up with the idea of reversing the existing Rollcall into a movable mouse-like device, so that customers did not have to be bothered with mounting holes for the earlier trackball device. Together with light pens and trackballs, it was offered as optional input device for their system since 1968. Some samples, installed at the Leibniz Rechenzentrum in Munich in 1972, are still well preserved. Telefunken considered the invention too small to apply for a patent on their device. The Xerox Alto was one of the first computers designed for individual use in 1973, and is regarded as the grandfather of computers that utilize the mouse. Inspired by PARC's Alto, the Lilith, a computer, which had been developed by a team around Niklaus Wirth at ETH Zurich between 1978 and 1980, provided a mouse as well. The third marketed version of an integrated mouse shipped as a part of a computer and intended for personal computer navigation came with the Xerox AT10 Star Information System in 1981. In 1982, Microsoft made the decision to make the MS-DOS program Microsoft Word mouse compatible and developed the first PC-compatible mouse. Microsoft's mouse shipped in 1983, thus beginning Microsoft hardware. However, the mouse remained relatively obscure until the 1984 appearance of the Macintosh 128K, which included an updated version of the original Lisa mouse. In 1984, PC columnist John C. Dvorak stated the mouse as a reason the Macintosh would fail.
Operation.
A mouse typically controls the motion of a pointer in 2 dimensions in a graphical user interface, GUI. The mouse turns movements of the hand backward and forward, left and right into equivalent electronic signals that in turn are used to move the pointer. The relative movements of the mouse on the surface are applied to the position of the pointer on the screen, which signals the point where actions of the user take place, so that the hand movements are replicated by the pointer. Clicking or hovering, stopping movement while the cursor is within the bounds of an area, can select files, programs or actions from a list of names, or, in graphical interfaces, through small images called icons, and other elements. For example, a text file might be represented by a picture of a paper notebook, and clicking while the cursor hovers this icon might cause a text editing program to open the file in a window. Different ways of operating the mouse cause specific things to happen in the GUI. Click, pressing and releasing a button. Left, single click, clicking the main button. Left, double click, clicking the button 2 times in quick succession counts as a different gesture than 2 separate single clicks. Left, triple click, clicking the button 3 times in quick succession. Left, quadruple click, clicking the button 4 times in quick succession. Right click, clicking the secondary button. Middle click, clicking the tertiary button. Left, single click, clicking the main button. Left, double click, clicking the button 2 times in quick succession counts as a different gesture than 2 separate single clicks. Left, triple click, clicking the button 3 times in quick succession. Left, quadruple click, clicking the button 4 times in quick succession. Right click, clicking the secondary button. Middle click, clicking the tertiary button. Drag, pressing and holding a button, then moving the mouse without releasing. Using the command drag with the right mouse button instead of just drag, when one instructs a user to drag an object while holding the right mouse button down instead of the more commonly used left mouse button. Button chording, aka rocker navigation. Combination of right click then left click. Combination of left click then right click or keyboard letter. Combination of left or right click and the mouse wheel. Combination of right click then left click. Combination of left click then right click or keyboard letter. Combination of left or right click and the mouse wheel. Clicking while holding down a modifier key. Moving the pointer a long distance, when a practical limit of mouse movement is reached. One lifts up the mouse, brings it to the opposite edge of the working area while it is held above the surface, and then replaces it down onto the working surface. This is often not necessary, because acceleration software detects fast movement, and moves the pointer significantly faster in proportion than for slow mouse motion.
Mouse gestures.
Users can also employ mice gesturally, meaning that a stylized motion of the mouse cursor itself, called a gesture, can issue a command or map to a specific action. For example, in a drawing program, moving the mouse in a rapid X motion over a shape might delete the shape. Gestural interfaces occur more rarely than plain pointing and clicking, and people often find them more difficult to use, because they require finer motor control from the user. However, a few gestural conventions have become widespread, including the drag-and-drop gesture, in which the user presses the mouse button while the mouse cursor hovers over an interface object. The user moves the cursor to a different location while holding the button down. The user releases the mouse button. For example, a user might drag and drop a picture representing a file onto a picture of a trash can, thus instructing the system to delete the file. Standard semantic gestures include crossing-based goal, drag and drop, menu traversal, pointing, rollover, selection.
Specific uses.
Other uses of the mouse's input occur commonly in special application domains. In interactive three-dimensional graphics, the mouse's motion often translates directly into changes in the virtual camera's orientation. For example, in the first-person shooter genre of games, see below, players usually employ the mouse to control the direction in which the virtual player's head faces. Moving the mouse up will cause the player to look up, revealing the view above the player's head. A related function makes an image of an object rotate, so that all sides can be examined. When mice have more than one button, software may assign different functions to each button. Often, the primary, leftmost in a right-handed configuration, button on the mouse will select items, and the secondary, rightmost in a right-handed, button will bring up a menu of alternative actions applicable to that item. For example, on platforms with more than one button, the Mozilla web browser will follow a link in response to a primary button click, will bring up a contextual menu of alternative actions for that link in response to a secondary button click, and will often open the link in a new tab or window in response to a click with a tertiary, middle, mouse button.
Variants. Mechanical mice.
The German company Telefunken published on their early ball mouse on October 2, 1968. Telefunken's mouse was sold as optional equipment for their computer systems. Bill English, builder of Engelbart's original mouse, created a ball mouse in 1972 while working for Xerox PARC. The ball mouse replaced the external wheels with a single ball that could rotate in any direction. It came as part of the hardware package of the Xerox Alto computer. Perpendicular chopper wheels housed inside of the mouse's body chopped beams of light on the way to light sensors, thus detecting in their turn the motion of the ball. This variant of the mouse resembled an inverted trackball and became the predominant form used with personal computers throughout the 1980s and 1990s. The Xerox PARC group also settled on the modern technique of using both hands to type on a full-size keyboard and grabbing the mouse when required. The ball mouse has two freely rotating rollers. They are located 90 degrees apart. One roller detects the forward-backward motion of the mouse and other the left-right motion. Opposite the two rollers is a third one, white, in the photo, at 45 degrees, that is spring-loaded to push the ball against the other two rollers. Each roller is on the same shaft as an encoder wheel that has slotted edges. The slots interrupt infrared light beams to generate electrical pulses that represent wheel movement. Each wheel's disc, however, has a pair of light beams, located so that a given beam becomes interrupted, or again starts to pass light freely, when the other beam of the pair is about halfway between changes. Simple logic circuits interpret the relative timing to indicate which direction the wheel is rotating. This incremental rotary encoder scheme is sometimes called quadrature encoding of the wheel rotation, as the two optical sensors produce signals that are in approximately quadrature phase. The mouse sends these signals to the computer system via the mouse cable, directly as logic signals in very old mice such as the Xerox mice, and via a data formatting IC in modern mice. The driver software in the system converts the signals into motion of the mouse cursor along X and Y axes on the computer screen. The ball is mostly steel, with a precision spherical rubber surface. The weight of the ball, given an appropriate working surface under the mouse, provides a reliable grip so the mouse's movement is transmitted accurately. Ball mice and wheel mice were manufactured for Xerox by Jack Holley, doing business as the Mouse House in Berkeley, California, starting in 1975. Based on another invention by Jack Holley, proprietor of the Mouse House, Honeywell produced another type of mechanical mouse. Instead of a ball, it had two wheels rotating at off-axis. Keytronic later produced a similar product. Modern computer mice took form at the École Polytechnique Fédérale de Lausanne, EPFL, under the inspiration of Professor Jean-Daniel Nicod and at the hands of engineer and watchmaker André Guinard. This new design incorporated a single hard rubber mouse ball and 3 buttons, and remained a common design until the mainstream adoption of the scroll wheel mouse during the 1990s. In 1985, René Sommer added a microprocessor to Nicod's and Guinard's design. Through this innovation, Sommer is credited with inventing a significant component of the mouse, which made it more intelligent. Though optical mice from mouse systems had incorporated microprocessors by 1984. Another type of mechanical mouse, the analog mouse, now generally regarded as obsolete, uses potentiometers rather than encoder wheels, and is typically designed to be plug-compatible with an analog joystick. The color mouse, originally marketed by Radio Shack for their color computer, but also usable on MS-DOS machines equipped with analog joystick ports, provided the software-accepted joystick input, was the best-known example.
Optical and laser mice.
Optical mice make use of one or more light-emitting diodes, LEDs, and an imaging array of photodiodes to detect movement relative to the underlying surface, rather than internal moving parts as does a mechanical mouse. A laser mouse is an optical mouse that uses coherent, laser, light. The earliest optical mice detected movement on pre-printed mousepad surfaces, whereas the modern optical mouse works on most opaque surfaces. It is usually unable to detect movement on specular surfaces like glass. Laser diodes are also used for better resolution and precision. Battery-powered, wireless optical mice flash the LED intermittently to save power, and only glow steadily when movement is detected.
Inertial and gyroscopic mice.
Often called air mice since they do not require a surface to operate, inertial mice use a tuning fork or other accelerometer, U.S. patent 4,787,051, published in 1988, to detect rotary movement for every axis supported. The most common models, manufactured by Logitech and Gyration, work using 2 degrees of rotational freedom and are insensitive to spatial translation. The user requires only small wrist rotations to move the cursor, reducing user fatigue or gorilla arm. Usually cordless, they often have a switch to deactivate the movement circuitry between use, allowing the user freedom of movement without affecting the cursor position. A patent for an inertial mouse claims that such mice consume less power than optically based mice, and offer increased sensitivity, reduced weight and increased ease of use. In combination with a wireless keyboard, an inertial mouse can offer alternative ergonomic arrangements which do not require a flat work surface, potentially alleviating some types of repetitive motion injuries related to workstation posture.
3D mice.
Also known as bats, flying mice, or wands, these devices generally function through ultrasound and provide at least 3 degrees of freedom. Probably the best-known example would be 3D Connection Logitech's Space Mouse from the early 1990s. In the late 1990s, Kontk introduced the 3D ring mouse. This wireless mouse was worn on a ring around a finger, which enabled the thumb to access 3 buttons. The mouse was tracked in 3 dimensions by a base station. Despite a certain appeal, it was finally discontinued because it did not provide sufficient resolution. A recent consumer 3D pointing device is the Whirl Remote. While primarily a motion-sensing device, that is, it can determine its orientation and direction of movement, Whirl Remote can also detect its spatial position by comparing the distance and position of the lights from the IR emitter using its integrated IR camera. Since the Nunchuk accessory lacks a camera, it can only tell its current heading and orientation. The obvious drawback to this approach is that it can only produce spatial coordinates while its camera can see the sensor bar. A mouse-related controller called the Spaceball has a ball placed above the work surface that can easily be gripped. With spring-loaded centering, it sends both translational as well as angular displacements on all 6 axes, in both directions for each. In November 2010 a German company called Exotic introduced a new concept of 3D mouse called 3D spheric mouse. This new concept of a true 6-degree of freedom input device uses a ball to rotate in 3 axes without any limitations.
Tactile mice.
In 2000, Logitech introduced a tactile mouse that contained a small actuator to make the mouse vibrate. Such a mouse can augment user interfaces with haptic feedback, such as giving feedback when crossing a window boundary. To surf by touch requires the user to be able to feel depth or hardness. This ability was realized with the first electroradiological tactile mice but never marketed.
Ergonomic mice.
As the name suggests, this type of mouse is intended to provide optimum comfort and avoid injuries such as carpal tunnel syndrome, arthritis and other repetitive strain injuries. It is designed to fit natural hand position in movements, to reduce discomfort.
Gaming mice.
These mice are specifically designed for use in computer games. They typically employ a wide array of controls and buttons and have designs that differ radically from traditional mice. It is also common for gaming mice, especially those designed for use in real-time strategy games such as StarCraft or League of Legends, to have a relatively high sensitivity, measured in dots per inch, DPI. Some advanced mice from gaming manufacturers also allow users to customize the weight of the mouse by adding or subtracting weights to allow for easier control. Ergonomic quality is also an important factor in gaming mice, as extended gameplay times may render further use of the mouse to be uncomfortable. Gaming mice are held by gamers in 3 styles of grip. Palm grip, the hand rests on the mouse, with extended fingers. Claw grip, palm rests on the mouse, bent fingers. Fingertip grip, bent fingers, palm doesn't touch the mouse.
Connectivity and communication protocols.
To transmit their input, typical cabled mice use a thin electrical cord terminating in a standard connector, such as RS-232C, PS/2, ADB or USB. Cordless mice instead transmit data via infrared radiation, CIRDAR, or radio, including Bluetooth, although many such cordless interfaces are themselves connected through the aforementioned wired serial buses. While the electrical interface and the format of the data transmitted by commonly available mice is currently standardized on USB, in the past it varied between different manufacturers. A bus mouse used a dedicated interface card for connection to an IBM PC or compatible computer. Mouse use in DOS applications became more common after the introduction of the Microsoft mouse, largely because Microsoft provided an open standard for communication between applications and mouse driver software. Thus, any application written to use the Microsoft standard could use a mouse with a driver that implements the same API, even if the mouse hardware itself was incompatible with Microsoft's. This driver provides the state of the buttons and the distance the mouse has moved in units that its documentation calls Mickeys, as does the Allegro library.
Serial interface and protocol.
Standard PC mice once used the RS-232C serial port via a D-sub miniature connector, which provided power to run the mouse's circuits as well as data on mouse movements. The Mouse Systems Corporation version used a 5-byte protocol and supported 3 buttons. The Microsoft version used a 3-byte protocol and supported 2 buttons. Due to the incompatibility between the two protocols, some manufacturers sold serial mice with a mode switch, PC for MSC mode, MIS for Microsoft mode.
PS/2 interface and protocol.
With the arrival of the IBM PS/2 personal computer series in 1987, IBM introduced the eponymous PS/2 interface for mice and keyboards, which other manufacturers rapidly adopted. The most visible change was the use of a round 6-pin mini DIN, in lieu of the former 5-pin connector. In default mode, called stream mode, a picosecond/2 mouse communicates motion, and the state of each button, by means of 3-byte packets. For any motion, button press or button release event, a picosecond/2 mouse sends, over a bidirectional serial port, a sequence of 3 bytes, with the following format. Here, XS and YS represent the sign bits of the movement vectors, 15 and YV indicate an overflow in the respective vector component, and LB, MB and RB indicate the status of the left, middle and right mouse buttons, 1 equals pressed. PS/2 mice also understand several commands for reset and self-test, switching between different operating modes, and changing the resolution of the reported motion vectors. A Microsoft Intelli mouse relies on an extension of the PS/2 protocol, the IMP/2 or IMP/2 protocol. The abbreviation combines the concepts of Intelli mouse and PS/2. It initially operates in standard PS/2 format, for backwards compatibility. After the host sends a special command sequence, it switches to an extended format in which a 4th byte carries information about wheel movements. The Intelli Mouse Explorer works analogously, with the difference that its 4-byte packets also allow for 2 additional buttons, for a total of 5. Mouse vendors also use other extended formats, often without providing public documentation. The Typhoon mouse uses 6-byte packets which can appear as a sequence of 2 standard 3-byte packets, such that an ordinary PS/2 driver can handle them. For 3D, or 6 degree of freedom, input, vendors have made many extensions both to the hardware and to software. In the late 1990s Logitech created ultrasound-based tracking which gave 3D input to a few millimeters accuracy, which worked well as an input device but failed as a profitable product. In 2008, Motion4U introduced its OptiBurst system using IR tracking for use as a Maya graphics software plugin.
Apple Desktop Bus.
In 1986 Apple first implemented the Apple Desktop Bus, allowing the daisy chaining together of up to 16 devices, including arbitrarily many mice and other devices on the same bus with no configuration whatsoever. Featuring only a single data pin, the bus used a purely poled approach to computer-mouse communications and survived as the standard on mainstream models, including a number of non-Apple workstations, until 1998 when iMac joined the industry-wide switch to using USB. Beginning with the bronze keyboard PowerBook G3 in May 1999, Apple dropped the external ADB port in favor of USB, but retained an internal ADB connection in the PowerBook G4 for communication with its built-in keyboard and trackpad until early 2005.
USB.
The industry standard USB, Universal Serial Bus, protocol and its connector have become widely used for mice. It is among the most popular types.
Cordless or wireless.
Cordless or wireless mice transmit data via infrared radiation, CIRDR, or radio, including Bluetooth and Wi-Fi. The receiver is connected to the computer through a serial or USB port, or can be built in, as is sometimes the case with Bluetooth and Wi-Fi. Modern non-Bluetooth and non-Wi-Fi wireless mice use USB receivers. Some of these can be stored inside the mouse for safe transport while not in use, while other, newer mice use newer nano receivers, designed to be small enough to remain plugged into a laptop during transport, while still being large enough to easily remove.
Atari standard joystick connectivity.
The Amiga and the Atari ST use an Atari standard DE9 connector for mice, the same connector that is used for joysticks on the same computers and numerous 8-bit systems, such as the Commodore 64 and the Atari 2600. However, the signals used for mice are different from those used for joysticks. As a result, plugging a mouse into a joystick port causes the joystick to continuously move in some direction, even if the mouse stays still, whereas plugging a joystick into a mouse port causes the mouse to only be able to move a single pixel in each direction.
Multiple mouse systems.
Some systems allow 2 or more mice to be used at once as input devices. 16-bit era home computers such as the Amiga used this to allow computer games with 2 players interacting on the same computer. The same idea is sometimes used in collaborative software, for example to simulate a whiteboard that multiple users can draw on without passing a single mouse around. Microsoft Windows, since Windows 3.1, has supported multiple simultaneous pointing devices. Because Windows only provides a single screen cursor, using more than one device at the same time requires cooperation of users or applications designed for multiple input devices. Multiple mice are often used in multi-user gaming in addition to specially designed devices that provide several input interfaces. Windows also has full support for multiple input mouse configurations for multi-user environments. Starting with Windows XP, Microsoft introduced a SDK for developing applications that allow multiple input devices to be used at the same time with independent cursors and independent input points. The introduction of Vista and Microsoft Surface, now known as Microsoft Pixel Sense, introduced a new set of input APIs that were adopted into Windows 7, allowing for 50 points cursors, all controlled by independent users. The new input points provide traditional mouse input. However, are designed for more advanced input technology like touch and image. They inherently offer 3D coordinates along with pressure, size, tilt, angle, mask, and even an image bitmap to see and recognize the input point object on the screen. As of 2009, Linux distributions and other operating systems that use Xorg, such as OpenSolaris and FreeBSD, support 255 cursors input points through multi-pointer X. However, current no window managers support multi-pointer X, leaving it relegated to custom software usage. There have also been propositions of having a single operator use 2 mice simultaneously as a more sophisticated means of controlling various graphics and multimedia applications.
Buttons.
Mouse buttons are micro-switches which can be pressed to select or interact with an element of a graphical user interface, producing a distinctive clicking sound. The 3-button scroll mouse has become the most commonly available design. As of 2007, and roughly since the late 1990s, users most commonly employ the second button to invoke a contextual menu in the computer's software user interface, which contains options specifically tailored to the interface element over which the mouse cursor currently sits. By default, the primary mouse button sits located on the left-hand side of the mouse, for the benefit of right-handed users. Left-handed users can usually reverse this configuration via software.
Mouse speed.
Mickey's per second is a unit of measurement for the speed and movement direction of a computer mouse. But speed can also refer to the ratio between how many pixels the cursor moves on the screen and how far the mouse moves on the mousepad, which may be expressed as pixels per Mickey, or pixels per inch, or pixels per cm. The directional movement is called the horizontal Mickey count and the vertical Mickey count. The computer industry often measures mouse sensitivity in terms of counts per inch, CPI, commonly expressed as dots per inch, DPI, the number of steps the mouse will report when it moves 1 inch. In early mice, this specification was called pulses per inch, PPI. The Mickey originally referred to one of these counts, or one resolvable step of motion. If the default mouse tracking condition involves moving the cursor by 1 screen pixel or dot on screen per reported step, then the CPI does equate to DPI, dots of cursor motion per inch of mouse motion. The CPI or DPI as reported by manufacturers depends on how they make the mouse. The higher the CPI, the faster the cursor moves with mouse movement. However, software can adjust the mouse sensitivity, making the cursor move faster or slower than its CPI. Current software can change the speed of the cursor dynamically, taking into account the mouse's absolute speed and the movement from the last stop point. In most software this setting is named speed, referring to cursor precision. However, some software names this setting acceleration, but this term is in fact incorrect. The mouse acceleration, in the majority of mouse software, refers to the setting allowing the user to modify the cursor acceleration, the change in speed of the cursor over time while the mouse movement is constant. For simple software, when the mouse starts to move, the software will count the number of counts, or mickeys received from the mouse and will move the cursor across the screen by that number of pixels, or multiplied by a rate factor, typically less than 1. The cursor will move slowly on the screen, having a good precision. When the movement of the mouse passes the value set for threshold, the software will start to move the cursor more quickly, with a greater rate factor. Usually, the user can set the value of the second rate factor by changing the acceleration setting. Operating systems sometimes apply acceleration, referred to as ballistics, to the motion reported by the mouse. For example, versions of Windows prior to Windows XP doubled reported values above a configurable threshold, and then optionally doubled them again above a second configurable threshold. These doublings applied separately in the X and Y directions, resulting in very nonlinear response.
Mousepads.
Engelbart's original mouse did not require a mousepad. The mouse had two large wheels which could roll on virtually any surface. However, most subsequent mechanical mice starting with the steel roller ball mouse have required a mousepad for optimal performance. The mousepad, the most common mouse accessory, appears most commonly in conjunction with mechanical mice, because to roll smoothly the ball requires more friction than common desk surfaces usually provide. So-called hard mousepads for gamers or optical laser mice also exist. Most optical and laser mice do not require a pad. Whether to use a hard or soft mousepad with an optical mouse is largely a matter of personal preference. One exception occurs when the desk surface creates problems for the optical or laser tracking, for example, a transparent or reflective surface.
In the marketplace.
Around 1981 Xerox included mice with its Xerox Star, based on the mouse used in the 1970s on the Alto computer at Xerox PARC. Sun Microsystems, Symbolics, Lisp Machines Incorporated, and Tektronix also shipped workstations with mice, starting in about 1981. Later, inspired by the Star, Apple Computer released the Apple Lisa, which also used a mouse. However, none of these products achieved large-scale success. Only with the release of the Apple Macintosh in 1984 did the mouse see widespread use. The Macintosh design, commercially successful and technically influential, led many other vendors to begin producing mice or including them with their other computer products. By 1986, Atari ST, Amiga, Windows 1.0, GEOS for the Commodore 64, and the Apple IIGS. The widespread adoption of graphical user interfaces in the software of the 1980s and 1990s made mice all but indispensable for controlling computers. In November 2008, Logitech built their billionth mouse.
Use in games.
Mice often function as an interface for PC-based computer games and sometimes for video game consoles.
First-person shooters.
Due to the cursor-like nature of the crosshairs in first-person shooters, a combination of mouse and keyboard provides a popular way to play first-person shooter games. Players use the X-axis of the mouse for looking, or turning, left and right, and the Y-axis for looking up and down. Many gamers prefer this primarily in first-person shooter games over a gamepad or joypad because it provides a higher resolution for input, so they are able to make small, precise motions in the game more easily. the left button usually controls primary fire. If the game supports multiple fire modes, the right button often provides secondary fire from the selected weapon. Games with only a single fire mode will generally map secondary fire to iron sights. In some games, the right button may also provide bonus options for a particular weapon, such as allowing access to the scope of a sniper rifle or allowing the mounting of a bayonet or silencer. Gamers can use a scroll wheel for changing weapons, or for controlling scope zoom magnification, in older games. On most first-person shooter games, programming may also assign more functions to additional buttons on mice with more than 3 controls. A keyboard usually controls movement, for example, WASD for moving forward, left, backward and right, respectively, and other functions such as changing posture. Since the mouse serves for aiming, a mouse that tracks movement accurately and with less lag, latency, will give a player an advantage over players with less accurate or slower mice. Many games provide players with the option of mapping their own choice of a key or button to a certain control. An early technique of players, circle strafing, saw a player continuously strafing while aiming and shooting at an opponent by walking in circle around the opponent with the opponent at the center of the circle. Players could achieve this by holding down a key for strafing while continuously aiming the mouse towards the opponent. Games using mice for input are so popular that many manufacturers make mice specifically for gaming. Such mice may feature adjustable weights, high-resolution optical or laser components, additional buttons, ergonomic shape, and other features such as adjustable CPI. Many games, such as first- or third-person shooters, have a setting named invert mouse, or similar, not to be confused with button inversion, sometimes performed by left-handed users, which allows the user to look downward by moving the mouse forward and upward by moving the mouse backward, the opposite of non-inverted movement. This control system resembles that of aircraft control sticks, where pulling back causes pitch up and pushing forward causes pitch down. Computer joysticks also typically emulate this control configuration. After its software's doom, the game that popularized first-person shooter games but which did not support vertical aiming with a mouse, the Y-axis served for forward-backward movement. Competitor 3D Realms' Duke Nukem 3D became one of the first games that supported using the mouse to aim up and down. This and other games using the build engine had an option to invert the Y-axis. The invert feature actually made the mouse behave in a manner that users now regard as non-inverted. By default, moving mouse forward resulted in looking down. Soon after, its software released Quake, which introduced the invert feature as users now know it. Other games using the Quake engine have come on the market following this standard, likely due to the overall popularity of Quake.
Home consoles.
In 1988, the educational video game system VTech Socrates featured a wireless mouse with an attached mousepad as an optional controller used for some games. In the early 1990s, the Super Nintendo Entertainment System video game system featured a mouse in addition to its controllers. The Mario Paint game in particular used the mouse's capabilities, as did its successor on the Nintendo 64. Sega released official mice for their Genesis Mega Drive, Saturn and Dreamcast consoles. NEC sold official mice for its PC Engine and PCFX consoles. Sony Computer Entertainment released an official mouse product for the PlayStation console, and included one along with the Linux for PlayStation 2 kit. However, users can attach virtually any USB mouse to the PlayStation 2 console. In addition, the PlayStation 3 also fully supports USB mice. Recently the Wii also has this latest development added on in a recent software update.